Swayam Prabha. Digital India. Educated India.
Abhishek Bhattacharya from IIT Kanpur. Now, in this course, although we will be using heavily various references and sources, but there are some broad textbooks for your reference. The first one is actually Material Science and Engineering, an introduction by Callister. This is a John Wiley and Sons book. This book is very helpful for this entire course. In fact, this course, when I offer it at IIT Kanpur, this is used as a textbook for this particular course. And similarly, there is this another book by Ashby and Jones, which is Engineering Materials and Introduction to Properties, Application and Design. So, while the first book more talk about the properties of the materials, the second book talks about application and design. So, from that point of view, the second book will be very helpful for us. The third book is specifically designed towards the case studies. So, that is material selection in mechanical design, that is by Ashby, and that is also very widely we will be using it towards the fourth series of fourth week onwards. We will be using the third book. And then the mechanics of composite materials, because I told you that once we explore all the engineering materials, we will think of how to mix and match such engineering materials to make more advanced materials, to tailor them towards certain applications. So, then the composite materials will come into picture, and towards that the Jones book could be a good introductory book. Finally, when I will talk about the smart structures or the smart materials and the smart structures, the Chopra and Shirohi's book will be very useful for us. So, thus in this entire course there will be these 5 books which we will be using, and it could be a very good reference if you want to get more in-depth knowledge in this subject. Okay. So, in today's lecture we will talk about history and introduction of engineering materials. Okay. So, basically we will first start with the materials as the human civilization actually progressed, how we had actually gone for the use of various materials. As you know that materials are actually the drivers of our society, and various applications. You think of transportation, without materials you cannot build an automobile, a car, a cycle, an aircraft. So, the entire transportation you need some material. You think of housing, without a material you cannot develop any home. So, there are also certain groups of materials are needed. For clothing you need materials, for communication like an antenna, there also you need materials which will be capable of receiving the signals or transmitting the signals. And then recreations, lasers, etc. For each and every purpose you will need basically materials all around yourselves in order to give you the life that we have today. But the world was not so easy and comfortable if you look back into the evolution of human beings. If you look back toward the history, you would see that we have started with things like the Stone Age, and then from Stone Age we came to the Bronze Age, then from Bronze Age to the Iron Age. So, phase by phase we have actually developed our materials, and thus we have reached today. So, if you look back actually to the Stone Age, so that is the beginning of you would say the usage of materials. Now, this Stone Age essentially was actually continued from 15,000 before Christ, which means when just the Homo sapiens was evolving, till about 2 to 3,000 before Christ. So, depending on the area that we are talking about, and the major implement by which the Stone Age is named is actually related to stones for various types of hunting purposes. Okay. So, that is why you would see that various shapes of stones, mostly these stones are actually made from what you call igneous rocks. Okay. So, and some of them are from metamorphic rocks. So, mostly igneous rocks. So, why? Because they give you very high strength. I will later on tell you that how today we are reinventing the history, we are developing new materials which are actually derived from these Stone Age materials. Okay. So, these materials that are used in the Stone Ages, they are basically explored from various volcanoes etc., and various rocks or mountainous areas, and a limited extent other than the stones, of course, bones and woods are also used, but since stone was the predominant element which is mostly used for hunting purposes, hence this era is named as the Stone Age era. Okay. And there is a whole lot of technology that evolved around it. Some of it have survived today, some of it has gone lost. For example, you know how to make a stone in so sharp, so that you can actually do activities like sieving using the stone, or you can actually make very fine holes on beads using the stone. So, all these things, as you can see here in this Nubian Museum of Egypt, there is a good collection of this type of stone tools. In fact, you can say that these are the beginning, very beginning of the lathe machines, which is mostly based on metals, but the principle that is used for that is roughly the same. So, that is the Stone Age era, I would say, which continued for a long time until the human beings have actually reached a stage when they had a situation of the basic needs which were covered by the stone or the use of the stones, and the civilization has to progress further. Now, as it happened that because of some chancy I would say kind of discovery, the Bronze Age ushered in from the Stone Age. So, during the Bronze Age what happened? These instead of the use of stone, now it is the metals which have come into the picture. Metals like the copper mixed with tin. In fact, initially copper is used in some places for some very small amount of time, but it was found that coppers are very much malleable and they are not that strong, so that you can make a useful implements or tools out of them. And hence, when they found this new alloy, again a chancy discovery that from certain ores, that if you mix actually copper with tin, you get something called bronze, which is much stronger. Then suddenly the Bronze Age has started, where the people have developed swords, daggers made of bronze. Okay, as you can see here, various types of bronze related things. There are also some examples of gold and other things, but that is mostly for the ornamental purposes. So, the venture with the metals, I would say, started with the actually bronze itself. If you actually think of the history of India, there are enormous evidences of Bronze Age in India. It actually people say it started at around 3000 before Christ or so. Of course, the exact timing there is still a lot of debate on it, and the use of such Bronze Age culture was found in Mohenjo-daro, Harappa areas, mostly around this part and the northwest part of India. And here, for example, one of the very beautiful evidence of the Bronze Age civilization is the dancing girl. In National Museum Delhi, you will find this small piece of bronze product which is made using something called a lost wax method. Okay, so, and it is very nicely described in many of our scriptures. For example, if you read Vishnu Puran, and similar such old scriptures, you would see that it is very nicely depicted there, that how you can make an initial model out of wax, and then this wax model you actually pour the molten metal into it, and in that process of course the wax is lost, that is why it is called a lost wax method, and you get the exact replica of the product that you are making. So, this kind of lost wax technique with bronze is used for making various types of not only sculptures or dolls, but also various types of pots or items of ornamentation. It is very heavily used. So, thus Bronze Age is actually it is widely found in Indian civilization, and particularly in the context of the Indus Valley civilization and Harappa civilization. Now, I would say it is not only the bronze, but also there are certain things like these the ceramics. Okay. So, later on I will actually tell you that the ceramic also came into existence side by side. In fact, ceramics played a very important role in the Indus Valley civilization, and we actually claim that India is possibly the first place where the ceramics and to some extent the ceramic composites were actually discovered, and they are hugely applied for potteries, for making bricks, for beautiful building constructions. So, ceramics played a very important role in all these things. So, during the Bronze Age, of course, the predominant material is bronze itself, but I would say that these ceramics also side by side came into the picture. Now, after that next came the Iron Age, and people say in fact that one of the reasons why the Indus Valley civilization was actually defeated by the Aryans is because the Aryans had better arms which are made of irons, and hence they worked much better than the bronze counterparts, and they won the battles. However, the point is that the Iron Age had actually been very widely distributed all over the world, and in India also I will talk about it later on, that southern part of India had a very good culture of an Iron Age. So, this started roughly about 3000 years ago, and it was found very soon that iron is a much better material in terms of hardness, strength, okay, and also you can make composites out of it, and you can make various types of variations of iron to the extent of steel, which of course came from the Industrial Revolution. Now, once the iron came, and slowly where not the iron has invaded us, for example, you think of the automobiles, the earlier automobiles were made of woods, but the 4T generations were actually made of steel. So, the steel dominated the automobiles. Of course, the entire railway transportation system got dominated by iron. People tried to replace the railway coaches by making aluminum material and aluminum based coaches, but they really did not get a success so far. And then of course, other things like aircrafts, etc. But in aircrafts, iron is more in the form of an alloys, partly because of its heavy weight. So, that is how Iron Age has really advanced from that 3000 years ago till today. It is continuing. Now, iron, of course, we have a very rich heritage. Just like I talked about the Bronze Age, Iron Age also we have a very rich heritage. If you have ever visited Delhi, you must have seen the famous iron pillar of Delhi. And if you want to know more about this, you can actually read a book by our own ex-late colleague Professor Bala Subramaniam of Material Science Department, who has written a beautiful book on the iron pillars, the mystery of this iron pillar, why it has not been corroded for thousands of years. In fact, he is the person who actually found out that the mystery lies in terms of how this iron was actually obtained, and the rich phosphorus content in some of the sources of iron is what actually gave that beautiful property of anti-corrosiveness in these iron pillars. So, this high resistance to corrosion because of the iron hydrogen phosphate hydrates actually. If you check this particular type of a system, in this particular reference you will see that there is a layer of crystalline iron hydrogen phosphate hydrate, which serves to protect it from the effects of the Delhi climate. So, that was like a very interesting part of early improvements or early applications of iron for making various types of products. Now, also please keep in mind that a column is predominantly a compressive force carrying system. This is important. I will later on tell you that from iron to steel, that is what has actually changed the world. So, iron now not only later on limited only for these kinds of columns etc., but also for making bridge, like world's first cast iron bridge is in England, it is on river Severn, and this is the first arc bridge. Now, this arc bridge configuration, that is very interesting actually. If you look at this arch part of the bridge, okay, so it is this particular part, if you look at it, that it is developed in such a manner that there will be only compressive load in each of the members of the arches. Okay. So, you have to keep in mind that this form of iron we are talking about, cast iron, they are very weak in tension, and since they are very weak in tension, hence you cannot really make a bridge where there will be a tensile force that will be working on the system. So, this is made design is done in such a manner that it will be predominantly compressive in nature, and that is the beauty of the arch bridge system. And in 1781 it was first developed, and that you may say as the first use of iron from general say applications like columns or chariots etc., to something like a large infrastructure system, for example, for the bridge system. Of course, at a later stage this is also used for the development of the Eiffel Tower, that actually showed the mighty power of the industrial revolution. So, that is the early stage of iron development. So, from there let us come to the steel part of it, because iron becomes much stronger in the form of steel. Now, it was kind of known to early people that if you, when you are making iron, basically from the raw iron, when from the ores, when you are actually melting it, and if you leave it in the furnace for some time, they found it to be harder and stronger. They did not know the reason, that the reason is because some amount of charcoal which is generally used to heat it up actually makes it stronger. This was very well understood by the southern part of ancient India. In fact, the steel that they used to prepare is known as wood steel. Even today, when we talk about steel, we always try to find out in Indian context that whether it is from the southern part of India or not, because people believe that southern part has a much better kind of knowledge of steel production. So, where is that myth comes from? It is actually because of this wood steel that had dominated entire medieval period in India. Now, there are other evidences of making steel in Roman eras and in the 3rd century AD in Chinese making steels, but wood steel is really very famous and in terms of the early advancement of steels. Of course, with respect to the industrial revolution, you get the modern era of steel making, the first one being the Bismarck, the famous Bismarck process. So, in the Bismarck process, as you might have studied in your basic courses, that it always starts with a Bismarck converter, okay, and where you are actually blasting the air blast injected into the molten pig iron, and the objective is that now you know that you have to mix iron with a limited amount of carbon. If the carbon content is too high, it will be harder, but it will be very brittle. So, you have to have an optimal content of carbon, something like 3.5 to 4.5%, and that you do through air blasting, hot air blasting, which actually converts some of the carbon to carbon dioxide, and it is good, but the material the ore is to be free from phosphorus. Okay. It is interesting that the same phosphorus was used from the anti-corrosion point of view in the Delhi iron pillars, but in the Bismarck process it works very well provided the ore is free from phosphorus. Now, there are some improvements to tackle the phosphorus, because this we are talking about in the background of Europe, and there the phosphorus is removed with the use of actually limestones in the Gilchrist-Thomas process. So, that is one improvement on the Bismarck process, which happened around 1860. To give you a kind of a time frame, we are talking about 1857, the famous Indian mutiny. That is the time when already they have caught hold of how to make a very good quality of steel, which means how to make very good quality of armaments. So, 1860 already the steel making process has advanced further from the Bismarck process. 65 came the famous open hearth process. So, that is also known as Siemens-Martin or open hearth process, and in this process what they do is that they actually mix the steel scrap here, okay, with the pig iron. So, that actually helps in terms of reducing the carbon content by dilution or oxidation. So, that is in 1865. Of course, at a later stage people have understood that how to use oxygen blast, because if you use air, what happens is that you get, along with oxygen, you get nitrogen and all other impurities, but you do not need the impurities, you need the pure oxygen in order to convert some part of carbon to carbon dioxide. So, that with the oxygen blast technique in 1953 or so, you get actually a very good kind of steel making. However, further with the advent of the electric arc furnace, you do not have to really generate heat with the help of fossil fuels anymore. So, the chance of carbon getting intruded beyond a certain degree is totally avoided in the induction furnace. Of course, it is more expensive, but it is a much more green process. So, thus there are a lot of developments of steel that has taken place, predominantly based on the iron, and you can say in some extent we are continuing with the iron age even today. So, one of the most important thing there is that the iron products, or so to say the steel products, you can actually recycling them even if it is older than 150 years. So, that means you think of it that how green it is for the environment, that you can recycle it again and again and again. That is the good part of iron. Okay. So, that is kind of very brief about the steel making process. Now, India's contribution, if I just highlight a little more in terms of the wood steel, because it is still a mystery that how the wood steel became so famous. It is like it is a kind of a, what you can say, a iron, it is a composite in which you have the tempered martensite or the perlite matrix of iron, and that actually is having enhanced strength because of the sheets of these microcarbides, and the source of these microcarbides are actually the woods that are used in that process of generating the heat. So, it actually keeps some kind of a banded pattern, a pattern of bands. That was the telltale sign of actually wood steel, and it became so popular that in the entire Mid East, there are these Persian phrases like a cut with an Indian sword, okay, or this Hindwani, that is Indian steel as the best in the world. So, that is the that was the kind of the marvel that the wood steel had generated. In fact, Faraday in his early days actually spent about 4 years studying the properties of the Indian wood steel. So, Indian wood steel is really something which was, I would say, one of the first ventures towards making a good product out of iron. So, that is why we should really take pride in this particular thing. Now, if you consider in the today's context, steel plays a very important role in our civilization. See, particularly for example, the railway tracks. We have the fourth longest railway network, something like 65,000 kilometer next to USA, China and Russia. And this railway network is possible because of the rail steel, which has a content of carbon of about 0.6 to 0.8% with some other alloys like manganese, silicon, sulfur, phosphorus, molybdenum, chromium and vanadium. But it's a very extensive and a robust network of application of steel. You can see there are various such things like this diamond crossing in Nagpur, for example, where you have the north and south crossing. Okay, so imagine the amount of wear and tear that these things will be placing, and the steel rail plays a very important role there. Similarly, you think of the Pamban rail bridge. Okay, so that is once again a marvel out of steel. In fact, I would tell you about another very early applications of steel, that is the Howrah bridge in Kolkata. If you look at it, it is basically a suspension bridge. Just like we have talked about the cast iron bridge, where it actually predominantly takes the compressive load. This is an example where it is like two cantilevers. It is a doubly balanced cantilever bridge, in fact it is called, and these two cantilevers come from two sides. So, because it is like two cantilevers from the two sides, so there is one cantilever from this side and there is another cantilever from this side. So, basically due to the load, the application of load in both the cases, there is a bending that you would not see in that cast iron bridge over river Severn. And this bending actually what it means is that if you take any member, you would see that the stress profile on the member is having both tension as well as compression in it. Okay? And it is this tension carrying capability of steel, iron, cast iron form, it does not have that. But once you mix it with a very kind of a controlled amount of carbon and some of the other materials, you get this beautiful property of steel, that it is equally good in tension and compression. And that is how these one of the longest, sixth longest cantilever bridge in the world was made possible because of the advancement of steel. So, that kind of glorifies the metals, the role of the metals and our advancements with the metals. Now, let us try to summarize this evolution of the materials. So, if you try to summarize this evolution of the materials, what you would see is that suppose 10,000 BC when we are talking about, at that time if you look at it, then you would see that there is a predominant use of stone, flint, etc. As I told you, that is the beginning of Stone Age. If you talk of other materials, the straw brick, I told you, the Indus Valley civilization, that is the beginning of ceramics. This is the initial part of material use. So, the straw brick, I told you, that is from the Indus Valley civilization. Then there is some use of wood skins and fibers, and that you may say that other than the like stones, etc., some of the organic elements like skins, etc., they are used for dressmaking. After that, the pottery, glasses are coming into picture, the discovery of papyrus, that is creating the paper, and of course, as you can see that the red line is expanding here, that is the metallic line. So, from the Stone Age, now there comes first the copper, then the bronze and then the iron, and this gulf is expanding more and more. Okay? So, if you look at till the medieval period, for example, you would see that by the time there are some refractory materials, there are some glues, but the cast iron takes a very predominant role. And then once we are beyond industrial revolution, you will see that the steel comes into picture, then the alloy steels come into picture, and then possibly beyond 1900s or so, I would rather say with the First World War and the Second World War around, we start to get a new materials. See, earlier in terms of polymers and elastomers, we had only organic materials like wood skins and fibers, glues or rubber, which is from the natural rubber. But it is around the Second World War or so that we have this nylon, polyethylene, etc., that got discovered. Okay. So, that started to play a very important role. We will see that after that onwards, once again their use is expanding. Okay. Today their use is continuously expanding. What else we are getting in the metals? After the alloy steels, then we the light alloys came into picture, particularly because of the development of the aircraft sector, and then of course the jet aircraft had initiated the development of super alloys, which is like a mixing of various types of metals like titanium, vanadium, chromium, etc., and it's like 33 metals together develops a super alloy. So, that's quite a feat of achievement in terms of advancement of metals. Then there are various types of formations of metals like glassy metals, like aluminum lithium alloys, dual phase steel, microalloyed steel, and some new super alloys. So, here it is like the development is slowed down, but mostly there is a quality that is actually increasing, not in terms of rapid increase in terms of quantity. If you talk of in terms of quantity, then you would see that the metal is shrinking now. So, post 1960 metal, again the use of metal is shrinking. What is expanding? Polymers and elastomers, that is expanding. We now are having very high quality polymers that is coming up, and composites, that is expanding. As I told you that composites are basically mixing of various types of materials. For example, we have the carbon fiber reinforced plastic, CFRP, glass fiber reinforced plastic, we have Kevlar, which is used for bulletproof jackets, we have metal matrix, we have ceramic composites. So, there are various types of composites that is coming up, and one very interesting thing is that you may say that the Stone Age is actually coming back here in a different format. The ceramics and glasses, they are actually their use is expanding continuously, the advanced ceramics. So, ceramics are taking the place of metals back again. That is very interesting. In fact, in this course we will see the power of ceramics that is happening in today's context. So, that is the summary in terms of the material evolution that actually we have seen in today's context. Thank you.